Hello guys, welcome to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapagod. Dear students, in the previous class we discussed some questions on international system of units. NEET questions we are solving. Dear students, come today we will move towards next problem on the system of international units. I will read the question first. The pair of quantities having same dimensions is, this is the question which is asked in 2013, dear students. Now what are the answers he has given? Impulse and surface tension. Second one, angular momentum and work. Third one, he has given work and torque. And fourth one, he has given Young's modulus and energy. In these four, you need to identify the one pair having same dimensions that you need to determine, dear students. Now so how to solve this numerical? Come, we will see today step by step. Dear students, still you not yet subscribe my channel, please subscribe and get more updates. Okay, now this is the problem he has given. So here is the some Young's modulus also he has given, work also he has given, torque also he has given. So we can see here now. Okay, so it will require, this diagram is required for Young's modulus. Okay, now what I will do, dear students, to solve this numerical, I will try to determine the dimensions for all the quantities what he has given. So first one, I will go with first one. There is a impulse and surface tension. So first one, what I will do here now, first one, I will try to obtain the dimensions for impulse. Okay, what is impulse, dear students? Now impulse is equal to, you can mark it here now. So impulse is equal to, what is that? Force into time, actually force into time. Okay, so force into time. What is force? Again Newton's second law, that is m into a into time. I will write it here now, fundamental quantities, that is time t. So I will write the fundamental quantities. Fundamental quantity for mass is m. I will write it m here now. Then it is a acceleration. So acceleration meter per second square. Then ml to the power of what? Ml t to the power of minus 2 I can write. Then multiplied with what? T. Here minus 2 is there, plus t to the power of minus 2 is there. Here t to the power of 1 is there. That means what? If nothing is there, that means what? 1 actually. So then what happens now? Add the powers of these two. Minus 2 plus 1. Then what happens now? So therefore what I can do now? Impulse. So the dimensions for impulse is equal to ml. Okay, ml t to the power of what? Minus 1, dear students. Now this is what? Dimension for impulse. This is what? Dimensions for impulse. Because I need to identify the two quantities, they are having same dimensions. For that what I will do, step by step I will try to obtain the dimensions for the each quantities, then only I can identify. Okay, fine. First impulse is done. Second one, surface tension. So I will write it, go with surface tension now. Now surface tension, fine. Dear students, that surface tension you can take it as a sigma. Okay, sigma we will take stress also, but you can take sigma, no problem. Sigma, that is nothing but what? Force per unit length, actually per unit length. I will write it here now, for unit length. Okay, surface tension is nothing but force per unit length actually. What is force actually, dear students? Now dimensions for force actually, that is nothing but what? Force, again Newton's second law, that is ma. I will write it as it is here now. So therefore surface tension sigma is equal to, what is the fundamental quantity for mass? That is m. So okay, acceleration again L t to the power of minus 2 divided by L is there. I will write it here L. Is there any cancelling term? Yes, there are two. There is a cancelling term, that is LL will get cancelled. So therefore what I can do now? Sigma is equal to m t to the power of minus 2. This is what, dear students? This is the dimension for what? Surface tension. Dimension for surface. Okay, fine. But dear students, here L term is not there, right? But L term is nothing but what? You can assume that L equal L to the power of 0. Anything to the power of 0 is nothing but what? 1. So I not written here now. That means what? L value is 0 here now. So that you can write, dear students. Okay, fine. Now, so that sigma you can write like this also. So therefore surface tension is equal to m L to the power of 0, that is anything to the power of 0 is nothing but what? 1 itself. So t to the power of minus 2. You can write in this fashion also. Both are correct, dear students. Now okay, fine. Now so first one is work. Next one, angular momentum and work. So next, third one I will write it here now. Okay, what is third one, dear students? Third one, angular momentum. Angular one minute. Third one, I will take it here, angular momentum. So what is that angular momentum, dear students? Now that is mass into velocity into radius, we can take it now, or distance we can take. Okay, radius we have to, you can take. So now what you can take here now, so then what will happen? Mass fundamental quantity is m into velocity is nothing but what? Meter per second. I can write it here, L t to the power of minus 1 into r is nothing but what? Meter, that is L, you can write fundamental quantity is L. Then what happens now, dear students? M, there L is there, power 1 is there, L power 1 is there, then it becomes what? L square, then it becomes what? T to the power of minus 1. This is what? Angular momentum. Angular momentum, you can write it now. This is the dimension for what? Angular momentum, that is represented by what? Small w. Okay, this is what? Okay, so now angular momentum is over. Next one is what, dear students? Next one, work actually. Fourth one, I will write it here now, work. So we know work is represented as capital W. So what is capital W? Is nothing but what? Force into dot product of displacement. So what is force? Again, Newton's second law, that is m into a. Distance is nothing but what? D. I will write it here now. Now I will write the fundamental quantities. Mass, fundamental quantity per mass is m. Then it is acceleration, that is L t to the power of minus 2 meter per second square. Again it is what? L is there. So therefore in dimension for work is equal to m into L square t to the power of minus 2, dear students. Now this is nothing but what? This is the dimensions for work actually. Okay, so now work we have calculated. Okay, fine. Next, work and energy, work and torque is there. Work already we have calculated. Next, what I will do? I will go with what, dear students? Fifth one. What is that? Torque. What is torque? Torque is represented as capital T. So therefore T is equal to, that is nothing but what? Force into perpendicular distance. How it is that, dear students? You can see here now. So torque is nothing but what? There is a force acting here. Okay, that you can mark it as a F, and it is having a distance, perpendicular distance from center to this circle, or you can call it as a drum also. It is what? R actually. The force acting to the center, that force into R is what? Torque actually. So that I have written it here now. Again, what is force, dear students, here now? What is force? We know already, right? Okay, so that is what? M into A. Again, distance R is nothing but radius, that is a distance. So what I will do here now? I will write it here, I will take it as a distance now. Okay, what is the fundamental quantity for mass? That is M. Again, L to the power of what? Minus 2. Again, it is what? L actually. So therefore, what I can do now? Torque is equal to M. Again, L to the power 1 is there, L to the power 1 is there, it becomes L square, and it becomes T to the power of minus 2, dear students. Now, fine. So now, this is what my final answer. So this is my dimensions for what? Torque actually. Dear students, just we can see here now, work and torque. L to the power of 2, T to the power of minus 2 is there. L to the power of T to the power of minus 2 is there. But this is correct answer, you know. Both the quantities, you can take work and torque. You can take work and torque, they are having same dimension. The work and torque, they are having same dimension. The same question he has asked now. I got the answer now. But I will try to calculate the Young's modulus, because again energy is nothing but what? Capacity to do the work. Again the dimensions for energy is what? Work itself. That is this is the answer. But you need to identify work and torque is over. They both are having same answer. But I will try to determine the Young's modulus dimension also. Then only I can give the final conclusion. So how it is that we can see here now, dear students. Now Young's modulus. Okay, so now I will write it here now. Sixth one. Okay. Just a minute. Okay, sixth one, I will write it here, dear students. Young's modulus. Okay, Young's modulus is represented by notation, that is E. What is Young's modulus? We know already, stress divided by strain actually, epsilon. So now what is actually stress? Stress we know already, F divided by A, 1 minute. So therefore, I can write it here, Young's modulus is equal to F divided by A divided by what? That is strain, that is original change in length to original length, dear students now. So that is the change in length to original length. I will take it here L. So therefore above equation I can write it like this now. So therefore E is equal to Young's modulus F divided by A into, I will take into numerator. So then it becomes L divided by what? Delta L, dear students now. Now I will substitute the dimensions here now. Okay. F is nothing but what? Force again M into A, then it is nothing but what? Area, capital A represents area, into what? This is L, so I will write it as small l and delta L, dear students now. Now what I will do here now, so I will try to write the E is equal to, what is the M? M fundamental quantity for small m, that is mass is equal to capital M, that is then acceleration meter per second square is there. I can write it here mLT to the power of minus 2 divided by what is area? Area is nothing but what? Meter square, that is L square. Fundamental quantity for meter is what? L actually, into that is change in length, again it is a L, then delta L, again original length to the change in length, both are having same dimension, that is L. Here dear students, this cell and this cell will get cancelled. Then what happens now? Here one L is there, one L square is there, that will get cancelled. Then M T to the power of minus 2 divided by L is there. So therefore Young's modulus is equal to M T to the power of minus 2. Then this L I will take it into numerator, then it becomes minus 1. I will rearrange it and I will try to write it in the mLT format. So therefore Young's modulus is equal to M L to the power of minus 1 T to the power of minus 2. This is what? Dimensions for Young's modulus. But just to compare, dear students now. So you can compare here ml T to the power of ml power minus 1 is there. Okay. But here you can see here now, this is also not correct. So that means what? Those quantities, they having same dimensions, but here we have calculated the dimensions for Young's modulus also, it is not correct. So hence what we can see, the dimensions for work and torque are same. Hence our correct answer is work and torque. This is the third one is the correct answer, dear students. I hope you understood today's class. If you have any doubts, you can comment and you can get the clarity. Thank you.